Okay, so we have already applied Newton law in rectangular components. Now we will move to another section, which is how to apply the Newton law in normal tangential coordinates. So when we describe normal tangential coordinates, we said that at any instant, UT frame will constitute the plane of motion. So I can consider that at this instant, I'm moving on an arc of circle, and this circle is of radius rho, okay, centered at O. So the instantaneous plane of motion will be the plane of this circle, and this plane is the plane containing UT, which is tangent to the circle, and UN, which is perpendicular to UT, directed towards the center of curvature. So this is why we say that when we deal with normal tangential coordinates in the binormal direction, this is a subscript for binormal, which is normal to both UN and UT. And since the instantaneous plane of motion is UN UT, this means that summation of forces along UB is always zero. But this can be helpful for us when we have force projections along UB. This will help us to add a third equation to our system. When all your forces are in the plane of motion, then you don't need this relation, because if you don't have any force along UB, no need to project. Zero equals zero. But if you have forces along UB, you should project on UB and say that sum of B equals to zero to relate your forces. We'll take a lot of examples on this. Now, all we have to know is the information we learned in chapter 12, how to calculate AT, how to calculate AN. AT is the tangential acceleration. It's equal to dV by dt. And AN is the normal acceleration. It's equal to V squared over rho. And we learned together in chapter 12 how to determine this radius of curvature. If it's a circle, it's equal to the radius of a circle. If it's a curve and y is given function of x, we have a formula to use in order to find rho. Now, let us do together some problems to practice on how to use UN UT. And we'll see together that in general, UN UT is one of the most helpful frames, because in this frame, we have the advantage of knowing AN. And AN is V squared over rho. So if we are able to calculate the radius of curvature and we have the speed, we have the advantage of knowing AN. So already one of our unknown is found. This is why whenever you have circular motion, or whenever you have a curve y function of x, you know the value, you know the function, think about normal tangential coordinates. Okay, so let us see this problem. This is a little bit challenging problem. It's very important problem, and we'll see how using UN UT will allow us to get a simplified solution. We want to determine the banking angle theta for the racetrack, so that the wheels of the racing cars will not have to depend upon friction to prevent any car from sliding up or down the track. Assume the cars have negligible size, a mass m, and travel around the curve of radius rho with a speed v. I will decompose the given with you to try to see how we should think here about normal tangential coordinates. If you when you watch Formula One, okay, you realize that the race is not horizontal. Your race is inclined. And this inclination is not random. It's well designed, okay? Now, one of the preliminary design of this inclination is the following. If I want to know what should be the inclination, let us say I don't want to have friction between my rod and my car. So as they are telling you, we don't want to depend upon friction. Because they said we don't want to depend upon friction to prevent sliding up or down. Yani our car should not go up and should not go down. It should just move on a circle. You see here these dashed lines. These dashed lines will mark circular paths. So if you look, when you look from the top in a Formula One race, you just see circles. You see circles. Okay, so from top, these dashed lines will mark circles, and cars are supposed to move on these circles. They are not supposed to slide down or up the track, because if you have sliding down or up, you have a risk of accidents between your Formula One cars. Okay, so you are designing your race such that each car should move on a circular path following these dashed lines. Now, to have this motion, to ensure circular motion without sliding up or down, we should satisfy, if you want, the relation of circular motion. So let's say rho should not vary. So rho is a constant. So each dashed line will represent a certain circle of a value of rho. And when we do the design, we say if we want to move at a certain speed v, let's say I want to move at a certain high speed v, and I'm designing based on constant velocity. Okay, I should find what should be the angle theta. This is the question. To not have friction. Because I don't have friction, the only forces that will act on my car are the weight and the normal reaction. Okay, so from the given, I understood that my Formula cars should not slide up and down. So they should move just on a circular path. Okay, they should not be subjected to friction. So the only forces acting on these cars are the weight and the normal force. And now, for these conditions, I want to get a relation between theta and the parameters of my problem, which are the radius of curvature of the circle and the speed v, the speed v that I impose on my car. Okay, so let us see how to relate these parameters. First, yes, yeah.
هن لما يعملوا لنا it should not يعني there should be friction to prevent sliding صح؟
صح.
طب كيف عم بيقولوا لنا there is no friction؟
لا هن عم بيقول اوكي ليك انت اذا في friction الفريكشن حتكون مقسومه maybe ل two directions صح؟ you have a friction along the incline يعني up and down. You might have a component of friction tangent to motion صح؟
Yes.
But what did they say? You are moving at a constant speed v. You are not accelerating or decelerating. انت عندك غير هيدي اذا في possible friction that is tangent to your curve, this means that you have a deceleration effect or acceleration effect. Did they mention anything here, or they just say that you are moving at a speed v?
No, it's a constant v.
Okay, so do you have any force along ut?
No.
No. Okay, so the only forces are in the no forces along ut. You only have and no friction sliding in the up down direction. So your only forces are the weight and the norm. This will ensure for you first constant velocity. Why? Because let us now draw un ut ub unit vectors. You will see that ut is tangent to the path, and since v is constant, no forces along ut. So of course I don't have friction along this direction. Okay, and because they said no friction to slide up and down, so also I don't have friction in this direction. This means that I don't have friction. I just have the normal and the weight. Okay.
Doctor,
Yeah.
yesterday قلت إنه الفريكشن بيكون لقدام هو اللي عم يدفش السيارة فإنه
مظبوط
لا يرجع will not take it into consideration.
مظبوط هو ليك الفريكشن بالسيارة في يكون عنده دبل رول، في يكون driving friction وفي يكون opposing friction. It depends on the mode of your car. يعني انت when you are accelerating اكيد الفريكشن حتكون driving, but when you put the brakes on يعني you are locking your wheel الفريكشن بتصير عندها opposition effect. Okay, so the friction that is tangential can have both, can be يعني in opposite directions. If it's playing a driving role it will be along positive ut, and when you put the brakes on it will play a negative role, it will be in the negative direction. Okay, هلا we'll see this in detail. You'll understand more these issues about friction when we deal with rigid body. Okay, so when we go to rigid body, when we deal with the car, we will understand how the wheels will operate, how the wheels can drive the car. So if your car is at rest and you are starting your motion, then what will happen is that your wheels are rotating like this. They are doing an action on the ground to this direction. Then the ground will do on your wheels a force that is a driving friction that is along this direction, which is favoring translation of your car. However, when you put the brakes on, what will happen? When you put your brakes on, you lock your wheel, you create a locking effect. Your wheel will not rotate anymore, they will just slide. Or يعني if you put braking slightly شوي you will reduce the rotational effect and you will increase the sliding effect. يعني بيقولوا إنه the wheels are rolling and sliding at the same time, they are slipping. Okay, so we say we have several possible conditions for the wheel. They can roll without slipping. Okay, they can roll with slipping or they can just slide. We'll talk about this in detail after, but I just want you to know that friction in cars can play a driving role. When they tell you it's a driving friction, it's a long direction of motion of the car. When you put the brakes on, it will in general play in opposition to translation, so it will be opposite to translation of the car. Here, since we have constant velocity, so no acceleration or deceleration here, I don't have any friction along UT, and they told me that I don't want to rely on friction to prevent sliding up and down. So no friction in both directions. This means the only forces are the normal and the weight. Once I determined my forces and I determined that I have a circular motion, always when you have circular motion, think about U and UT. Okay, let me represent, if you want, U and UT in from two views. I will take first the view of the race. So if I take just the profile view, I will see this. I have an inclined race, and this is my car. I will treat my car as a particle. So I just consider it as a point. Okay, and now what are the forces acting on it? I have its weight and I have the normal to the car. Okay, so this is N and this is W. Now, how is UN, UT, UB? Keep in mind the track of motion is a circle. So UT, UN are within the circle. And since the circle is horizontal, so UN, UT is in the horizontal plane. So if you look here, your center of rotation will be somewhere here. So if you move along the horizontal line, I have the center here, let's say. And imagine you are looking at your car, it's from top, it's rotating about O. Okay, so UN, if I want to represent now my vectors, this is UN. UN is always in the plane of motion. The plane of motion is horizontal. Okay, and UN is directed towards the center of rotation. So this is UN. in this figure, ut is towards us, because look, this is your formula car. It's moving, it's the velocity is tangent to the path, and ut is a long velocity. So the velocity is towards us. Okay, so in this view, I can represent ut by a point with a circle to say that ut is towards me, perpendicular to the screen. So this is ut. Now, as we said, in un, ut, ub should be perpendicular to both un and ut. So it's perpendicular to the plane of motion. Since the plane of motion is a horizontal circle, then ub is perpendicular to the circle, so it's vertical. So this is my ub vector. Okay. Now, once I put the frame, this is the most important step. If you put the un, ut, ub in a good way, then it's simple projection and you get a system of equations to solve. So please pay attention for this step. It's one of the most important. If you confuse un, ut, ub, all your equations will be altered. Okay. Now, to imagine more the situation, I will also draw for you the top view. So this is the profile view. Okay. Now a top view, if we are looking from top, we see that the car is rotating on a circle. So let us represent the top view. I will also use colors, different colors. So this is the track that you will see from top. Okay. Your origin O is the center of this circle. Your car is here now. Your car is here. Okay. Now in this frame, in this view, I have ut is tangent to the path, and the car is coming towards us. So you will see this. This is ut. un is directed towards O, and ub here is perpendicular to the circle. So it's we can represent it by a point and a circle. So it's pointing up. This is ub. And if you want to present your forces, this view is much better, because look here, the weight first will be perpendicular to your system. So if you want to present the weight in this figure, you can represent it by a cross with a circle, because it's along minus ub. So this is the weight, and un is challenging to see here. Yani you should decompose it into two components. As you can see, un has two components, one along here, un, one along ub. So this is why this view is better to project forces. Okay. Here you can say that n has two components, and I can present them. I have one component nb. I will put it here to not have a lot of forces on the same point. N along ub will be vertical up, and you have n along un. Okay, we'll call it the normal reaction along n direction. So of course this view is better, because in this view we can project n. Here we cannot see it well. So this is why I will work on the first view, on the profile view. If I look at the profile view for the weight, it's very simple for me. The weight is along minus ub, so no problem with it. Just for the normal, it has two components, one along un, one along ub. So I should project it. To project it, I need the angle. I need what is the angle between n and ub, or what is the angle between n and un. If I look at my figure, the race angle is theta here. And as you can see, the incline is perpendicular to N, okay? And UB is perpendicular to the horizontal. This means that the angle between these two lines is equal to the angle between UB and N. This is a first method to say that this angle is theta. If you didn't pay attention for this, no problem. You can look at the figure like this. This is theta, and this is an alternating angle. So this is also theta, okay? And because N is perpendicular to the incline, if this is theta, this remaining part will be 90 minus theta. This means that N is doing with UN an angle of 90 minus theta, and is doing with UB an angle of theta. Okay? Any question on how we found the forces or the angles? Let me check your charts. Yes, Ribal, I will repeat how I put the vectors. Look, always UN UT is the plane of motion, okay? So first you should imagine, what is my plane of motion? Since it's a Formula 1 race, you can, when you look at when you watch Formula 1, if you pay attention, your cars will move along these dashed lines. And these dashed lines are circular, of circular form. So if you take the camera from the top, you will see a horizontal circle. So your plane of motion is a horizontal circle. And always UN will be towards the center of rotation. So if I look at my car here, okay, this car will be traveling on a circle of a certain center here somewhere, okay? And since I have that UNUT is in the horizontal plane, then when I want to represent this view, I have UN along the horizontal direction like this, okay? And UT is always following velocity, because your velocity is tangent to the path, so UT is perpendicular to UN in this way. So this is UNUT. You can see it also better in this view. In this view, if I look from top, I have a circular motion. UN is directed towards my center. UT is tangent to the path. I can represent them in this prof view and in this view. If I look from the profile view, I will just see UN because UT is perpendicular towards me, okay? Okay, what is, why isn't UB along N and UN parallel to the ground? Look, how can UB be along N? UB is perpendicular to the motion, to the plane of motion. Your plane of motion is a horizontal circle. If I give you a horizontal circle, UB should be perpendicular to it. So how should be UB vertical? It cannot be, UB cannot be horizontal, because your plane of motion is a horizontal circle. So if you look at your cars that are moving on a horizontal circle, UB should be perpendicular along the perpendicular direction to the circle. So it cannot be, the only possibility is that UB is along the vertical line. Okay, and UN, look, you mean UN should be like this? You want to take UN parallel to the ground? This is your ground, you mean? Okay, you should not confuse two things. Your car is not moving along this direction. This is not a line of motion of your car. This is just a contact line between your car and the race. But if you look at your car, if you observe its motion, it's moving along a horizontal circle. It's not moving along this line. Okay, so your circle is, the center of your circle is not along this direction. So if it's along this direction, this means that you should move in a inclined circle, which is not the case. your formula car your formula car is moving on a horizontal circle. So UN cannot be along the incline. Okay. Okay, it's fine, Ribot. Okay. Who asked also a question? Theta part. Yes, Hashim, I will repeat the angle theta. Look, I will draw it again. Look, you have a race. The angle of this race is theta. So this angle here is theta. Okay. Your normal reaction is perpendicular to the contact. The contact line, this is the contact line. The incline is the contact line between your wheels and the ground. Okay. And we know that whenever you have contact, the normal reaction is perpendicular to the contact line. So this is N. Now you want to determine what is the angle between N and your vectors. Your vectors of interest here are UN, UB. This is UN. UN is horizontal and UB is vertical. Okay. So you need or to determine the angle between N and UB or to determine the angle between N and UN. If you look at this figure, you have that this angle here, these two angles are alternating angles. So this is theta. And because N is perpendicular to the incline, this means that the angle between N and UN is 90 minus theta. And therefore, the angle between N and UB is just theta. Another method to say this, UB is perpendicular to the horizontal, N is perpendicular to the incline. This means that the angle between these two lines is equal to the angle between these two lines is equal to theta. Okay. We didn't take Hassan, we didn't take the engine force of the car because look, in general, what will happen is that in an acceleration phase, you will have to put a certain engine force to reach a certain speed. Whenever you reach the desired speed, okay, if you don't have any opposition to your motion, you can just maintain a constant speed. Then of course, this is a preliminary design. It's not 100% realistic because you will always have an engine force. بس انتوا تخيلوا when you are moving on a certain road, أول شيء you accelerate, and once you reach a certain stage بسرعة very high velocity, you maintain it constant. Okay, so here assuming, as I said, they are neglecting any frictional effect, any resistant effect. So once I reach a certain velocity v, if I don't have any source of losses, I can maintain it without having to exert any additional engine force. Okay. Okay, it's fine, Hassan. So once I draw the free body diagram, I am ready to the next step. The next step is to project my forces along the axis. And I have N already, and don't forget the weight. This is the weight. So let me use my equations. First, here, some FT will not be helpful for me because, as we said, there is no forces along the tangential direction, which is perpendicular to the screen. My forces, which are the normal and the weight, are both in UNUB plane. So they don't have any projection along UT. This was expected because I know that I'm maintaining constant velocity. So AT is 0, and I verified the, and this was expected because V is constant. I'm moving at this, I'm maintaining a certain speed V. Okay, now, so this equation will not be of help for me because we don't have any force along UT. I will move to the other two equations. I have sum Fn equals to MAN And I will take the advantage that in UNUT frame, I know the expression of AN. So I can write that sum of normal forces equals to M times V square over the radius of curvature. Now, let me project along UN, okay? I have the weight is perpendicular to UN, zero projection. The normal is doing with UN an angle of 90 minus theta. So I can do or n cosine 90 minus theta or n sine theta. So I can write that n sine theta is equal to mv square over rho. This is relation number 1. Okay, this is equation number 1. This equation is not enough for me because what I want to do, I want to express theta function of v and rho. Okay, but already here I have two unknowns in this equation, which are the normal and theta. So I need another equation to eliminate n and just have the expression of theta. To do this, I still have one relation that I didn't use, and which is sum of forces along UB is equal to 0. And here this relation will be very helpful because I have projection of forces along UB. So this will allow me to relate my normal and my weight. Okay, so along UB, I have the projection of n. Since n has an angle theta with UB and it has a positive projection on UB, I can write that plus n cosine theta minus the weight minus mg equals to 0. And this means that n cosine theta is equal to the weight is equal to m times g. This is relation number 2. If you observe relation 1 and 2, you can easily eliminate n by just dividing equation 2 by equation 1. So let us say, or 1 over 2 as you like. If I do 1 over 2, if I divide equation 1 by equation 2, what do I get? I get n sine theta over n cosine theta equals to mv square over rho divided by mg. And now look, I will have several simplifications. N will cancel out, m will cancel out, sine theta over cosine theta is tan of theta. Okay, so I can say that I obtain the following result. I will write it here, the final result. Tan of theta is equal to v square over rho g. Okay, so what is theta? Theta is tan minus 1 v square over rho g. So if I just give you what is the, let's say, the speed I want to move on the circular path, what is the radius of curvature of my design, you can determine a preliminary value of your angle theta. Okay, any question on this problem? Salman, some of no forces on FT because your only forces, if you look at your free body diagram, you just have the normal and the weight, and both of these forces are within the vertical plane. They are along UN and UB. Okay, And since UT is perpendicular to the vertical plane, so these forces will not have any projection along UT. So when you write some FT, you will get just 0. And you expected this because you are designing based on a constant speed. So sum of forces along UT should be 0. Any other?
And
Yes?
yes, the sum of forces along UB is also the same.
Sum of forces along UB is always 0, but why here it's a useful equation? Because you have projection of forces. N has a projection on UB, and the weight has a projection on UB. So when you write sum of B equals 0, you will relate N and weight. However, when you apply on UT, do you have any projection on UT?
No.
No projection on UT. You will just get sum of T equals to 0. And sum of T is equal to MAT. This means that no tangential acceleration. AT is 0. And you expected this because you are designing based on constant velocity V. Okay.
Thank you.
Welcome. Any other question? We used the fact that the car will not will not depend upon friction to prevent the car from sliding when we considered the free body diagram of your car. Because you might tell me, maybe I have a friction acting along the incline. But because they told you there is no friction to prevent any car from sliding, so you don't have friction along this direction. So this helped you to say that along this direction, I don't have friction. And because you are designing on a constant speed, you used this to say that I don't also have friction along UT. Okay. No, this sentence said that there is no friction along the incline. But because I'm moving at a constant speed V, this means that I don't have also a friction force along UT. So this here it should be, maybe they should add the word constant V to stress this. Okay, constant V means no friction along this direction. And when they said it will not have to depend upon friction to prevent any car from sliding up or down, means that there is no friction along an incline, along the inclined line. Okay.
Professor?
Yes.
نحن moving on with a constant velocity ما ضروري يكون معناته انه ما في friction. يعني انا في يكون مثلا constant velocity ما معناتها يعني معناتها انه ما في acceleration. اوكي انه sum of forces equal
Okay.
zero.
Look,
بس
you
أنا
can
في يكون
have
مثلاً
look, you
في
can
قد
have
friction.
opposite, you can have opposite forces. يعني يمكن يكون عندك resistant force of air مثلا, for example. أو if you're بس عادة الريس تبع يعني in the race if you want عندك effect of يعني resistance of air we can neglect it in general. Okay. فأنت عادة تيكون عندك friction بده يكون أو you are applying an engine force أو you are putting your brakes on. بس هي الفكرة إنه أنت when you move in a constant regime مفروض تكون إذا بدك وصلت يعني كان مرقت بأكسلريشن phase وصلت للvelocity اللي أنت بدك إياها و you maintained it. يعني how you maintain a certain velocity you can just if you want يعني أنت بس تسوق السيارة بس توصل